Hey, what's up, Logic fans? How's it going? Welcome to another video, and today we're going to cover our 7th section on quantificational syntax. We're going to look at how conditional proof and indirect proof work in the context of quantifiers, of syntactic deductions involving arguments with quantificational apparatus. Let's rock. Okay, so the best way to understand this is to start by looking at an actual example. So here we have an argument, okay, and we're going to be doing CP first. Forget about IP just for a little bit here. We'll get to it. With CP, we've got this premise, and it says everything is F, and we're supposed to conclude from that that if A is G, then A is both F and G, and intuitively that's a valid argument, right? It's pretty simple. So what I want you to do is I want you to figure out, okay, in order to solve this, we're going to use CP. And what tips us off to use CP is the fact that the desired conclusion is a conditional. This is its antecedent, this is its consequent. So following the same procedure of CP outlined in Chapter 3 when we were just working with propositional logic, what would be your assumption in this case? Go ahead and pause now and see if you can figure that out. Okay, hopefully you've been able to figure it out, but your assumption would just be the antecedent, GA, and you would just write assumption, right? And what are we looking for in this case? Pause now and see if you can figure out what we're looking for. All right, and you're just looking for the consequent, right? So this is what you're looking for. So that would be our assumption, and then we have to attempt to get this from these two things now. So instead of just the premise, we also have this available. Well, looking at what we're trying to get, FA and GA, we've already got the GA. That's very nice. What if, how do we get FA? Well, conveniently, looking at this, we just get FA this way, and that would be universal instantiation on 1. And then, of course, building to the thing that we're looking for, FA and GA, by conjunction on 2 and 3. And then, bang, you're just going to have your conclusion here in 5. In other words, we're going to now discharge the assumption because we found what we wanted from it. And so we get the first thing we assumed, arrow the last thing we got, and that is QED with the exception of CP 2 through 4. So as you can see, it works in the exact same way structurally as it did in Chapter 3 when we were working with propositions. It's just that now you've got some fairly more sophisticated things like GA instead of just capital A or something, right? And otherwise, structurally, it works the same. All the same rules apply to it and all the same strategies. So let's just keep working through some examples so you can feel comfortable with it. Okay, so for the second example, what I would like to do is I'd like to sort of leave the first one up here so that you have a reference point to sort of think about how you're doing this. And I'd like to do one that's a little different. So in this case, we have a conditional. In this case, we have a conditional. But the antecedent and the consequent are a little bit different. These antecedent and consequent have quantifiers in them. This one did not. So let's look at this case. I'm going to give you a chance to prove it right now, and then we'll come back and do it together. I'll give you a hint along the way. Pause now and give this one a shot. Okay, so here's your hint. You're looking at a conditional, so you assume the antecedent. This is the antecedent, so that's all the same, right? And you assume, and you write assumption and what you're looking for, and what we're looking for is the consequent, which in this case is this. So this is all structurally identical. None of that is changing, okay? So see if you can't figure it out from here. Pause now. Okay, hopefully you're able to figure it out, but, you know, we're looking for at least one thing is both F and G, which is a categorical I statement, right? And so, fortunately, we've got something here that's F, and we know that everything is G, so if we want some one thing to be both F and G, it's going to have to be the same thing. Remember, we should always existentially instantiate as soon as possible. So we existentially instantiate here, and then using universal, we can go to the same thing because it applies to everything. If we had universally instantiated first, then V would have occurred on a previous line, and we would not have been able to invoke it here following the rules of existential instantiation. So EI first, UI second, combine, find what you're looking for right here, and then discharge, and you write the first thing you assumed, arrow the last thing you got, which is here, and that is the solution to the problem. All right. Okay, for this particular problem, I want to break it up into two sort of stages for you. So we've got a premise and we've got a conclusion. Now, this problem can be solved without using CP, and perhaps much more directly. But we're practicing CP here, and so that's the way we're going to use it. And I want to illustrate a certain point with this problem. So here, in this case, it is not obvious at all what CP assumption you should make. I mean, where's the conditional, right? Okay, so that's going to be step one for this problem. It's a certain strategy you can use, even though a problem might not look like you could use CP for it. If you get stuck, you might be able to find a clever application of CP. And the way to do that, or at least one way to do it, is to look at the conclusion, which I've put over here for us, and I want you to strip it of quantifiers. This is just scratch work, and then convert it into a conditional. Okay, so all you need to concentrate on right now is stripping this of quantifiers and converting it to a conditional. Pause now and see if you can do that. Okay, hopefully you were able to figure it out, and I just used a pretty simple way of doing it here. There's other ways you could do it, but first thing to do is get rid of the quantifier and you universally instantiate. We should universally instantiate because we know we're going to be going to the universal quantifier. So we're going to go to U, all right, and that leaves us with just this thing with U's in it. Okay, now we need to convert that to a conditional. Well, it looks like it's set up for De Morgan's, so if we do De Morgan's through, we end up with this, double negate a little bit to clean up, and this is perfect. We can just use impla, and boom, there's a conditional. So even though, like, supposing we were stuck and we wanted to make an assumption to maybe get started and help ourselves out, we didn't know what assumption to make because there wasn't an apparent conditional. What we did was we thought about the conclusion for a little bit, and we found out that, aha, here's kind of an occluded, hidden, secret conditional that could be of use. And so what we're going to do is we're going to go ahead and use that. So what we're going to do here is we're going to assume this, GU, which is right here, and we're going to write assumption, and we're going to look for the conclusion of that, right, or the consequent of that. So we're going to be looking for FU. So with that sort of start on the problem, see now if you can't finish it and get to this, and we'll come back and do it together. So pause now. Okay, hopefully you're able to figure it out, right? We've got GU, we're looking for FU, and we've got this premise to play with. So let's go ahead and instantiate it. That gives us FU or not GU, and that's perfect. It sets up a disjunctive syllogism to get FU out of, but we have to observe the niceties, right? So we got to flip this, the not GU around, got to double negate the GU so that we have the negation of the left disjunct of this disjunction here, and then we spit out FU. And then having found what we were looking for, we discharge our assumption. When we discharge the assumption, what happens? We got the first thing we assumed, arrow, the last thing we got right there. So all of this is remaining the same. And now it's just a matter of putting it into the desired form, right? We want this, so it's just a matter of manipulating it into that form. And how do we know how to do that? Well, guess what? We did it right here when we reverse engineered the conclusion. And so this gives you the order sort of backwards, right? Impla, double negation De Morgan, UG, impla, double negation De Morgan, right? And then universal instantiation because we were going down. But it sort of gives you the pattern right there how to do it. Now, you could have just universally generalized this right away. Okay, and then you could have, because these are all rules of replacement, you could have gone inside that and then manipulated it into this form if you had wanted, but I did it the other way, and you can proceed either way. But this is a really useful strategy to keep in mind, right? If you're stuck, and you may not have been on this particular one, but on other problems, if you're stuck, can I make an assumption to help myself out a bit, get something new on the board? Well, what assumption should I make? Well, let's think about how we could manipulate the conclusion into a conditional, and that'll give you a clue as to what kind of assumption you should be making and what you should look for in order to solve the problem. All right, so let's take a look at yet another one, and we're just sort of building in complexity here, looking at ever more sort of difficult constructions that you might have to build. And in this case, you've got a conditional for a premise, and then you've got an existentially quantified statement ranging over a conditional here. And so this one can be a bit tough, but the way to do it, the way to figure out what to assume is, again, to look at this, which is not a conditional, which is an existentially quantified sentence, and try to think about in your mind's eye what it would be if it weren't existentially quantified, but if it were just a straight up conditional, what might it look like? And that can give you a clue as to what assumption you should make and what you should be looking for in order to solve the problem. So go ahead and see if you can't convert this into a straight up conditional. Strip the quantifiers off and see what you're left with as a conditional. Pause now. Okay, hopefully you've had a chance to figure this out, but the big idea is you just take them off one by one. We'll remove the EY, and this will become a V, right, because it's existential. And for all X, we'll just make that a U because we suspect that we're going to have to go to an all at some point, so we want the U in there. And those are the kinds of little changes you can make as you go along, just to sort of make sure you get everything exactly right. Sometimes some trial and error is needed there, but okay, here's our conditional, and of course that is going to be what we use to solve the problem. So with that hint, see if you can't just from this get from this premise get to this conclusion using CP and knowing that that's a conditional of interest here. Pause now. Okay, so final hint for this one, you're going to assume the antecedent and look for the consequent, which is what we have here. So using what you see here and using your new assumption, can you build to this thing? And when you do, discharge and see if you can build this construction, okay? So see if you can finish it from here. Pause now. Okay, hopefully you've been able to crack this one, but the basic idea is we got the A here and we got the A here, but this one's in terms of an existential, which we're allowed to do, and so what we do is we existentially generalize in order to build this similarity, which sets up modus ponens to crank this out, and once we've cranked that out, it's easy to use existential instantiation to get the desired thing. Right, now that we've got the desired thing, we discharge our assumption, and so we write the thing we assumed, arrow the last thing we got, and bang. And then it's just a matter of, okay, I got the thing I wanted. How did I build it? Oh yeah, I built it this way. I'm building this thing, right? So first the universal, which is going to go on the A, right, leaving the existential one alone, and then existentially instantiating this sentence so that EY goes to the left and it wants it in terms of Y, and we replace the B, and boom, we're done, right? So I hope you're really appreciating how much this sort of reverse engineering the conclusion a bit can be helpful in illuminating the way, and oftentimes it can point the direction of what to assume for CP. And it can also, as we'll see, point the way for what to assume using IP. But we're out of time on this video, so let's spill this lesson into another video. We'll see you on that one.